Hi, everybody. Welcome to the Futurum Tech Podcast. I'm your host, Daniel Newman, Principal Analyst and Founding Partner at Futurum Research. Very excited about this Futurum Tech Podcast interview series that we're having today following the third generation Xeon Scalable processor launch from Intel. We're going to have an interview with Wei Li from Intel. And I'll have him on in just a moment. We're going to really focus this on the launch, but really talking a lot about AI, ML, and thought leadership in that particular area, because that is where Wei spends his time. I'll let him tell you more about that in a moment. These interviews are always really fascinating. I hope you can take the time. We'll spend about 20 minutes with him. It's going to be a great conversation. Now, quick disclaimer, I do have to let everybody know that this show is for information and entertainment purposes only. And while we will be talking to executives from publicly traded companies about their businesses, please do not take anything we say as investment advice. All right, without further ado, I'm going to welcome Wei to the show.
Hi, Daniel.
Wei, welcome to the Futurum Tech Podcast interview series. Thanks for joining me today.
Yeah, I'm very glad to be here. Thank you for inviting me.
Yeah, it's great to have you. So many of your peers have graced our show over the past several years. We've had experts on AI and Edge, 5G, and of course, a big topic is AI and ML. And I know that's an area you spend a lot of time on. But why don't I not spoil your introduction and give you a chance to introduce yourself? Why don't you tell everybody a little bit about the work you do at Intel?
Okay, great. So I'm a vice president of machine learning performance, and what that means is I lead a AI software team, and actually I have to say I lead a group of magicians. And they actually do magic for AI. You know, they are very innovative, and they take on aggressive goals, take on aggressive schedule, and they will hit it. So it's amazing, you know, to work with these guys. And our goal is actually, our role is to make AI run fast. And as you know, AI has been a lot of compute intensive. I've used a lot of data and so on. So making it run fast is actually critical. And in all my career, I've been in this business of making computers run fast. You know, even ever since I was a grad PhD student, many years ago now, and I worked on making supercomputers run fast. And since I joined Intel, I worked on getting data center and cloud servers run fast, as well as smartphones and tablets. So in the last more than 5 years so I have a team to work on making AI run fast, and that has been a amazing experience. Because I worked, as I said, in the business for a long time, AI has been probably one of the most challenging and also most rewarding experience. Just look at what we've done. I mean, the software optimization we have done. If you download our software, you can get to up to 100x performance gain. Who can get 100x easily, right? I mean, and we actually give people for free. You don't even pay for the 100x. You just download our stuff.
No, that's great. It just made me laugh a little bit. I almost that's a really big gain, Wei, and that's something that everybody's paying a lot of attention to. Are these performance gains? And of course, AI is really subjective, and I'm going to dig into that a little bit more with you in terms of, you've got the training end, you've got inference end, you've got common workloads, you got the GPU end of the things, which Intel is getting deeper and deeper, and then you of course have what you launched yesterday and talked about in your third generation, which had a lot of enhancements, generation over generation, but also against the competition. You guys in some of the more common workloads showed some really great gains. So there's a lot of positivity there. By the way, I checked out your LinkedIn because that's what people do these days. And I see you talked about PhD grad student. For everyone out there though, Wei's serious business. Cornell, I believe it was.
Yeah.
Graduate, did your PhD there, and then you're also you're in the Valley there, and I believe you at least part-time adjunct teach over at Stanford. I'm sure a few people have heard of that school.
Yeah, it's right here. Actually, it's biking distance for me to Stanford.
It's a lot of people dream of someday attending there. And if you ever get there for computer science, you might want to look up Wei and see if you can take one of his courses if he happens to be doing his adjunct thing at that time. So let's hop into a little bit more about the AI. It's a hot topic right now. It's becoming more democratized. People are experiencing it more in their everyday life. Talk about your experience in the years you've been in this. The evolution has to have been pretty, magnificent, for lack of a better word, from what you started to where we are today.
Yeah, it's been amazing, right? So I more than 5 years ago, it was before I was seriously doing the AI software. We're working on mobile devices, and I actually had a team. We actually developed a testing robot that can actually detect mobile application failures automatically, right? So it was using computer vision. We have a camera sitting on top of a mobile phone. It can actually detect when something fails. It can detect, right? So save a lot of time. It used to be we actually had to hire human testers to do this, and sometimes people think the human testers are fun because you get paid to do game testing every day, but it was not a fun job. You end up testing very same thing day in day out, right? So somebody even quit on the same day, right? So we developed this robot to do testing, and that save a lot of time, save effort, right? Now fast forward to today. We've seen things that is way beyond computer vision, right? We've seen people, when you and I go shopping, wherever you go shopping, you'll get a lot of product recommendation, right? And you get the voice assistance, you get smart search, all of these things. These things are all happening, and then also what's happening is on the people side. I mentioned I had an engineering team working on this. So now, not only the big cloud companies are working on this, the enterprise of any kind, people are working on AI, right? And the people are working on not only the business side of AI, but also consumer side of AI, where, so I have a teammate of mine, they want to have some fun. So they worked on something called neural style transfer. So they take Intel TensorFlow and run it on Intel Xeon. And yeah, I'm not sure, you probably know neural style transfer. So you get two images, you can take on the style of the other image, right? So imagine you get a photo, Daniel's photo, together with Picasso's painting, right? You can merge these things, take on a Picasso style of painting of Daniel, right? So it's a very cool thing, right? And more than that, I've seen high school students, right? So people, I wouldn't name names here. A high school student create a deep learning model to predict NCAA basketball tournament. Right, so who will be the winner of NCAA tournament? And he just took took a 1 semester Python class in high school, and he learned PyTorch by himself, right? And he got data on the internet, and then did the training on Intel laptops. So before you know it, he has a model, right? So and he's almost right actually in predicting this year's winner. It's just one step away. It's the team he predicted lost in the final, but it was very close, right? So things are just happening as we speak. So AI is going to be everywhere. That's why I believe I think one of the things I'm just a true believer of is AI is going to be everywhere.
It's funny. It's funny you said all that. What the algorithm probably couldn't predict, and you as a college professor and someone that spent a lot of time on a campus understand, is unlike professionals, there's a little bit more of an erratic or inconsistent nature of amateurs. And what I'm saying is, like the final game, I don't know if you watched it, but the one team came and played extremely well, and the other team almost looked off. That on another given day, it might have been his model might have been right, but because there's variables with college-aged humans that are not necessarily able to be monitored or managed to quite to that same level of perfection as something more binary.
Exactly.
It was really interesting, and that's a great example of it. I got a lot of ground to cover with you, so I'm going to keep moving here, but I want to talk about competition. So, Intel has had a really good few weeks, and not that it hasn't had a great history, but it had a rocky sort of few years with some delays and things that sort of weighed on the company. You had in your world, for instance, Nirvana came, then Nirvana went, but then Habana came, and now that seems to be very exciting. we've seen DL Boost inside of Xeon continue with with certain accelerated workloads has done very well. But it's in a comparison to say how Intel has performed in server and notebook, where it has really big market share. In AI, it's had to acquiesce a little more of its market share while it's been, while guys in your team and all these machine learning wizards, as you call them, are working to build what's going to be next. But, I guess, talk to me about that, because, you're typically a category leader, and right now you're an incumbent, but you're not the incumbent. And, how is Intel kind of playing catch up and then planning to eventually lead potentially in the AI space?
Yeah. So as you alluded to, AI is a very competitive market. It's there are a lot of players inside, and we are not necessarily leading everywhere. And so we but we do lead, I believe, in what I called CPU AI. And as you can see, CPU is everywhere, right? Because when we talk about AI everywhere, it's natural to start with something which is already everywhere, which that is CPU. And the CPU is very unique. CPU AI, what I call is unlimited AI. You can run any workload, right? You can run not only AI workload, you can also run non-AI workload, and even within AI workload, you can run deep learning, machine learning, big data analytics, and people need all kinds of different types of AI. So if that's what you're looking for as a IT manager or as a developer, you need something that can do everything you want, and CPU is a right solution for you. And in the past, several generations, we have been adding a lot of features. You mentioned DL Boost already, right? So because of these features we're adding, and because of the software optimizations we're being adding in the past several years, and I would say, in the CPU AI, we are a clear lead. Performance was much better than other CPU alternatives for AI. Now, I just remind me. One of the benefits of a pandemic is I got a chance to do biking more frequently. So I start with a hybrid bike. I can go anywhere I want. I can go around town. I can go to the bay. Not far away from here. Around the San Francisco Bay, you have a paved trail. You have a gravel trail, and I take the bike to the mountain. You can go anywhere you want, right? But on the other hand, if you want to. If I want to, I also have a race bike, right? So if you want to run as fast as you can, take the race bike. But race bike can only run on certain roads. But I haven't not got a mountain bike yet, and I probably won't get an electric bike for a long time, right? So it's the same as Intel, that we are investing in not only CPU. But we do believe CPU is a foundation, because people may have underestimated CPU. CPU is a foundation for AI, and then we also invest in other accelerators. We have a GPU, and we also have Habana, you mentioned already, and actually my team works on both CPU and GPU. So our job is also to make AI software run as fast as possible on GPU as well.
My assessment, by the way, was that there are always going to be those that live and die by the benchmark, float points, OpenVINA or OpenSSL. They're going to look at a benchmark and say, this processor, this one, and I always say, if you're really leading with ecosystem, business requirements, digital transformation, milliseconds on all but the most high power required workloads are probably pretty insignificant, meaning that most humans can't even discern the difference between how quickly they got a data point from an SAP query using one chip or another, even if one's much better, because you're talking milliseconds in most cases. It's such a small fraction. But you are always going to have people that focus on that. I tend to focus more on the business outcome. I always say Intel, from a general purpose understanding of what all the things a CPU can do, has a very good approach to partnering at the cloud, at the enterprise, at the edge, with the operators. And and has a very good approach in terms of the software partnerships, like I mentioned, SAP and other workloads where acceleration is important to make sure that those workloads have been designed to run optimally, because there's still those Pareto aspects of a business. These are the things that companies are doing all the time. Let's make sure those things we've optimized. And yeah, maybe there's a certain type of high HPC requirement where an A100, from NVIDIA might be the right, piece of hardware. And like you said, there's mountain bikes, there's racing bikes, there's electric bikes, there's motorcycles, and even when you get to motorcycles, there's Harleys and there's racing bikes. They're not the same. So I think that's a great analogy. I want to talk a little bit more on that edge to cloud use case, though. How is Intel approaching sort of that rapid proliferation? I heard this a lot yesterday. You're in the cloud, you're in with the enterprise, you're in with the edge. Where does AI sit with that, though?
Yeah, so AI is going to be everywhere, right? AI is going to be in the cloud. AI is going to be on the edge, at the edge, and actually we do expect edge AI will grow very significantly, right? So there's some data says by 2025. 3/4 of AI will be at the edge, right? I mean, which is very logical because edge is where data started, right? So it's good. It's natural to move your compute to the edge, right? Now on the edge side, it will be a similar story though, because Xeon has been used at the edge, and the same sort of trade-offs people are making, which is the simplicity of the compute system here, and where they can run all kinds of workloads. Right, on edge you may want to run all kinds of workloads also, right? And is it easier for you to just start on the general purpose CPU like Xeon? And now it could still mean at some point you want more, let's say, power performance, right? It's like a race bike example here, because quite often it's probably sufficient for you, right? Because like we're talking about milliseconds. On Xeon, you can get down to millisecond range already, right? And it can solve your problem, right? Now, if you want to be more than milliseconds, hey, we have accelerators also. We have a vision accelerator. We have FPGA. We have all kinds of things. We have GPU, and so it's just a variety of things we can all do. And I think the combination of all of these will get us to be AI everywhere here. Now, edge is also very nascent, right? I mean, it's there's a software play as well, right? The software play, and that's why we've been working with partners, and we've been, we have a edge solution called OpenVINO, which is very well designed for edge inferencing, and it's targeting multiple hardware targets, all the way from CPU, GPU to VPU, accelerator, and FPGA. So people can move seamlessly. You can start from CPU without code change. You can move to FPGA to other and to VPU if you want, right? So software play a key role in terms of helping people make their decisions on the hardware side.
Yeah, absolutely. And let's build on that a little bit. The company made a lot of announcements last year, one API, a number of software. And I think anybody that's kind of tracking this space agrees that foundational software layer is an enabler, meaning you can put all the horsepower on the planet into the silicon, but you need to have that software that enables development to happen quickly and ideally very open for various environments, and people can learn it. Talk about Intel's approach, what you're doing to expedite development, create flexibility, and from a software standpoint.
Yeah. So let me know. This is dear to my heart, right? Because I run a software team here. So I want to go from top down here, because I want to say from the developer perspective, what do you see, right? From a developer perspective, people take things like TensorFlow. People take things like PyTorch. People take things like scikit-learn, XGBoost, these things, right? So our job is to make sure all of these things are well optimized on Intel platforms, and luckily we actually have a very rich ecosystem, right? Because historically all these things are running on CPU, right? So naturally we already have these things, and now the question is how do we optimize better? So my focus on the software side is actually two parts. One is performance, and the other is productivity. So on the performance side, we want to make sure these are all well optimized on Intel platform to what I call roofline, hardware roofline, right? So we should go all the way to what hardware capabilities are, right? Because my hardware friends always remind me, I put in so many silicons there, you cannot leave them wasted, right? You have to get all the benefit from it. So that's our goal, to get the best performance out of it, and we've been doing quite a bit of that. So in the Bay Area, wherever I go, people wanted to start hardware AI accelerator companies, right? You probably have a lot of proposals to go for VC money and all that stuff, right? But for what we do, we have what I call AI software AI accelerator, right? The example I mentioned earlier, get to 100x for free, right? You can just download these Intel optimized TensorFlow and scikit-learn, all these things. You can get very significant in order of magnitude performance gain here. So that's the performance we're working on here. Now, the productivity side is also very important because, as you know, AI is smart, but development of AI is actually not so smart. Because it's amazing when I start looking at AI. I love math theory and all that stuff. Right? So because I was expecting a very nicely theoretical background for AI and all these things, but what I saw was very experimental, right? So it's sort of the scientist in me looked at the AI, say it's not really science, but the engineering in me say it's a good engineering. So we do a lot of engineering of AI. You have all these parameters you have tuned, what people call hyperparameters. It's a try error, right? So how do we make it more efficient to get AI work done? And that's another thing we're doing. So we're building tools to do this. For example, we're putting a DL boost, integer 8 operations inside hardware. So how do you go from a floating point 32 application to an integer 8 model? That process usually takes days to do this, right? And in our competition, if you do that on their platform, it takes 1,000 lines of code and a long time to do that stuff. So we have a tool we actually can reduce from days to minutes, right? So automation. That's the power of automation. And inside the tool, we use AI also. So we sort of eat our own dog food. Use AI to do AI, right? So all these things are built on top of one API. You already mentioned one API, and one API for the XPU strategy. One API is critical, right? Because you want to create a programming abstraction to unify all these XPUs, right? For people like our team, if we develop new AI software on top of this, it should be easy for us to move from one target to the other target, and that's a great idea. I mean, and the abstraction has two components to it. One is the language side, the DPC++ language. The other is a set of APIs for domain-specific libraries. And one DNA is the Intel implementation for Intel platforms. But we're also talking to other companies. We have seen other companies developed one DNN on ARM, for example, right? So it's an open API. People can implement on all kinds of targets, and I think that's good for the industry. I mean, industry-wide, it is good for us to have something uniform, consistent, and make it everyone's life much easier, right?
Absolutely. And with your Pat Gelsinger's announcements of your foundry ambitions, I guess it's a little bit more okay than ever before to be a little bit pro ARM or pro other chips, right? Because you guys may very well be involved in building and helping to manufacture those chips at scale in the coming years. So, but no, I think your point too is as it's kind of that high tide rises all boats, right? As these different software frameworks get adopted, the use gets adopted, it grows scale, more demand, more wafers, more chips, more volume, more use cases. Yeah. Everybody wins. I think the disaggregation and the XPU strategy is really great. Of course, we know 20, sometimes even 30% of the CPUs, resources get invested in things that are network infrastructure and data center infrastructure support rather than application processing. So as you're able to abstract more of those things away from the CPU becomes a bigger force in doing the things that you're talking about for accelerating workloads. So there's a lot of really interesting things happening concurrently. I only got a few minutes left here, and I've really enjoyed this way. You've been a great guest. For everybody out there that's listening, it's great to get these insights. You can definitely tell that if I let you, you could get really technical. Our audience is a good mix of technical and business. So I want to make sure we don't get too far. But the way I always try to make things real for people is talking about use cases. And so if you take a minute and just share a couple, I'd love to hear a couple of, what you would consider to be real powerful use cases that you're seeing all this work you're doing coming to life.
Yeah, so I'll just give you a few. I mean, I can spend hours talking about all kinds of use cases. Even and as I mentioned, things have moved quite fast, right? We've changed quite a bit in the past 5 years or so. So I'll just say, let's say I'm not sure if I have time for all 4 use cases, because I know we can go all the way from healthcare, right? Healthcare is very interesting. Everybody's talking about getting, applying AI in healthcare, and finance. Everybody cares about finance also, right? And manufacturing, and the thing I care a lot is sports, right? So in all these areas we have use cases here.
Well, as I tell you, give me 2. Talk about, I saw a list. Talk about 2 of them, and what I'll do too is in my show notes I'll put some links to some other stuff that people can read about. But I thought you had a couple of really cool ones. I'd love to hear about the SGX on the financial fraud, because I think that's a hot topic. And I think the sports one's cool because everybody likes money in sports, right? I mean, so
okay. Let's go for money first. So financial fraud. As you know, these are becoming, there's a way of life in the modern time. And so there's a company called Silent, and it's a pretty good name, Silent, and so they use AI to detect frauds, right? And now as you know, inside the financial industry, data is private. I mean, I wouldn't want everybody to see my financial data and all that stuff, right? So it is so it's a challenge to build a model. On one hand, you want to leverage data from everybody else, and on the other hand, you don't want to share the data with the model builder, right? So Intel, inside Intel hardware, we have a security feature called SGX, which stands for Software Guard Extension, and we're using that security feature that allows you to do something called federated learning. Federated learning means everyone contribute, but I'm not sharing data with others, right? So you get the best of both worlds, and with that, they build a good AI model for this, and we see the same capabilities used in healthcare as well. I mean, you can imagine, the healthcare data is also private, right? So that's one example of using Xeon effectively. Now the other one is sports. So we have Intel together with another company called Access, and they developed something called 3D athlete tracking. And with that, you can actually track athletes, and actually you can do modeling and all that, and you can get insights about their velocity, acceleration, and biomechanics when they're sprinting, right? And all that information, you can find out through this AI model. And actually, a few weeks ago, I'm just curious, as you know, I'm very interested in technology. I want to get inside, so I actually get a person to present in our internal tech forum, and I got to see what kind of algorithms built inside. It's interesting because it's actually not a single algorithm. It actually has a few, there's a machine learning algorithms, there's deep learning algorithm. It's just a variety of things people need to do in order to build a use case like this.
Well, first of all, Wei Li, thank you so much for joining me here today on the Futurum Tech Podcast interview series. I will say that I'm super big fan of what is going on with confidential computing. So the Silent case is very interesting. Hopefully I can share some details with our community and audience here so you can read more about SGX and potentially about this use case. The sports one, though, really near and dear to my heart. I'm a huge soccer fan or football, depending where you are in the world. But I'm also I also really like golf. And I am wondering if somehow AI could help me with the mechanics of my golf swing, because Anytime I've watched it on video, I've just said to myself, like, that is not at all what I see in my head when I'm doing it. So I know I can do better. But at the performance level, you have to imagine, we're already near perfection with these athletes. I mean, we're going to get them to the point where we are hitting optimum performance to that nanosecond with their mechanics, their running, their jumping, and it's just going to make sports awesome. But I think, to your point, before I say goodbye, I think what I really took away from what you said today is AI will be everywhere. And there are going to be many different ways that people are going to be able to consume it. There's frameworks and software and hardware, and it's going to be bringing all these things together. And clearly, Intel is in the mix in a big way, playing in the cloud, at the data center, in the enterprise, and at the edge. And at this point, though, I just got to say thanks. I'm going to post you off to the green room.
Okay, thank you.
Thanks, Wei Li. I'll be right back with you.
Okay.
All right, everybody. Well, that's the show today. I want to thank Wei Li again from Intel. What a great bit of insight following that third generation Xeon Scalable launch from yesterday. Not just really so much about the launch, but really just about the whole state of AI, where we're going to see it in our lives, and how Intel is approaching it from the hardware layer all the way out to the abstraction and software layers that you heard him mention. Go ahead and hit subscribe, join our show, stay part of the Futurum Tech Podcast community. We really value having you here. Go ahead and follow us on Twitter at Futurum Research, and check out Wei Li, all the things out there. He had a great 10-minute keynote on AI. We'll put that link in our show notes as well. For this episode of the Futurum Tech Podcast interview series for Futurum Research, I've got to say goodbye. Thanks again for tuning in. We'll see you later.